All right. The first thing we're going to talk about is just basic graphing when you have an inequality, just to remind you of what that looks like. When you're solving an inequality, you're not solving for one number. So with equations, typically, I mean, they're polynomials, but if just a standard 1-degree equation, you have one answer. X equals something, one answer. But when you're solving inequalities, you're actually giving me a set of numbers as your answer. And the way we represent a set of numbers is with a number line. And so anytime you solve for an inequality, you're actually solving for a set of numbers that fits or makes that inequality true. And so just a reminder, when you're graphing these, you're going to have a circle somewhere on the number line and you're going to shade to the right or to the left, okay? Open circle means that it is just greater than or less than, like this one right here. That's why this circle is open. It actually does not include 5. If it had an or equal to, we would color this in because it does include 5, okay? So just greater than, less than, open circle. If it is or equal to, we would do a closed circle to indicate that it also includes it. Let's look at the properties that have to do with this. Now, these same properties were true for equations as well. Transitive properties, if A is less than or equal to B and B is less than or equal to C, A is less than or equal to C. Addition, subtraction, multiplication, and division. For addition and subtraction, it's identical to an equality. You add or subtract the same thing to both sides. It does not change the inequality, all right? But for multiplication, negatives will change it, okay? So if it is greater than 0, if it's a positive number, you multiply and divide exactly like you would. If it is a negative number, remember negative just means changing it to the opposite, okay? And so since we're multiplying or dividing by a negative number, we're changing both sides to the opposite. We are also changing the inequality sign, okay? It will flip the sign because you are changing the meaning of both sides when you multiply or divide by a negative. You're literally changing it to the opposite. And so anytime you multiply or divide by a negative, you'll notice this flips, right? So we go from less than or equal to greater than or equal to, from less than or equal to greater than or equal to. Multiplication division is the only thing that's different, and that is only when you multiply or divide by a negative. All right, so let's look at examples here. Rather easy examples. Solve each inequality, graph the solution. You're doing exactly the same thing as we did with equations. You're going to get the variable by itself and then divide by whatever's in front of the variable. So for this first one, we're going to add our 12. We have 3x is less than 15. And then we are going to divide by our 3. So we get x is less than 5. And then we're going to graph it. We're going to go to 5. It is open circle because it is just less than. And we are going to shade to the left because we want things smaller than 5. All right. B, if you have a distribution, you're going to treat that just like you would an equation. Take the 5 and distribute. We have 6. Remember, we can't add the 6 and 5. We have to distribute the 5 first, so leave the 6 alone. 5 times 2 is 10. 5 times negative x is negative 5x. We do want to combine our like terms here. And then we are going to continue solving by subtracting our 16 over, right? Then on the left-hand side, we have our negative 5x. On the right-hand side, we have 25. Here we are dividing by negative 5. All right, because I divided by negative 5, I have to flip my inequality. And I get x is greater than or equal to negative 5. Because it's or equal to, close circle right here. Everything bigger because it is greater than. So for example, my variable is less than my number, right? And so I'm going to shade less than. Here it says -2 is greater than or equal to n, but in relationship to my variable is less than or equal to my number. So I'm going to shade to the left. So always pay attention to where your variable is. Your variable is less than your number. Your number is bigger, so your variable or your shading should go to the left of the number. Special cases. So there are special cases where you have no solution or all real numbers as solutions. And it's basically if you get a true statement or a false statement. All right, so what's going to happen with these is your variables will go away. You'll get rid of all your variables and you'll just have two numbers. And you're seeing if the statement that you get with the two numbers is true, well, then it's going to work for everything. If it's false, it's not going to work for anything. All right, and so that's basically what we're looking for when we get a special case or when our variables cancel each other out. So let's look at this first one. We're going to distribute our 2. So we have 2x minus 3 is greater than 2x minus 10. When I move my variable over, you can see that both of them cancel. So I get -3 is greater than -10. Is that true? Negatives. -3 is bigger than -10. That will always be true. You cannot present a situation where that's not true. And so because of that, that is all real numbers. And so my answer is going to be all real numbers, right? And then my whole number line is actually shaded. And I can just shade it, arrows on both ends, the entire number line, because it's going to work for any number that you put in there. Meaning I could pick any number from -infinity to +infinity and plug it into this inequality and it will be true. All right. Look at the next example here. Distribute your 7. You get 7x plus 6 is less than 7x minus 28. You can see that your 7x's will cancel here. And you get 6 is less than -28. That is never true. Never true. And so your answer here is just the empty set. Nothing on your number line should be shaded. Nothing is going to make that true, no matter what number you put in there. So empty set would be your answer there. Or no. What did you get? All real numbers or no solution? All real numbers. You should have gotten a true statement there, right? And then your number line would be your solution. What about B? No solution. You should have gotten a false statement there. All right, and then what about C? If possible, find values of A such that 2A plus A is greater than X. Has no solutions, and then has all real numbers as solutions. What would you have to do there? So for the first part, you could say for all A that are less than or equal to 0, right? 0 makes it untrue, and anything less than 0 makes it untrue. So then what would make it all real numbers? Yeah, so anything greater than or equal to. Actually, you could just say, you don't have to say greater than or equal to there. You could just say greater than 0. And that would be all real numbers. All right, all real numbers. The band shown at the left, which I did not make a picture of, but they appear to be a marching band of some sort, agrees to play for $200 plus 25% of the ticket sales. Find the ticket sales needed for the band to receive at least $500. All right? So when you're interpreting inequalities, you need to pay attention to what they want. We know that they're going to get a base amount of $200. In addition to that, they're going to get 25%, 1/4, 0.25, however you want to write it, of the ticket sales. X being the ticket sales that we don't yet know. At least, is that greater than or less than? They want at least $500. Greater or equal to, right? The very minimum they want is $500. That means that they want what they actually get paid to be either $500 or more. Okay, greater than or equal to. And so we're just going to solve it. Setting it up is obviously the most difficult, which even that is not that hard, but you just need to pay attention. All right. And then what do I do now? If you do fraction, it's, I think, easier. We're going to multiply both sides by what? There we go. So x is greater than or equal to 1,200. If you did decimals, you would have 0.25 and you divide by 0.25, which is a little bit longer. So they need $1,200 in ticket sales. Ticket sales need to be $1,200 or more here for them to receive at least $500. All right, so try check understanding number 3. All right, let's go over this one. Graph the solution. So for the first one, you would add your 1. You would have 3x is greater than negative 27. Divide by 3. X is greater than negative 9. On the right-hand side, you'd subtract your 7. You get 2x is less than 12. And then divide by 2. X is less than 6. So we have greater than negative 9, less than 6. These are both open circles because it's greater than the smaller and less than the larger. It does cross over for everything in between. So that would be my answer. Everything in between, open circle on both sides. Compound inequalities are and or. So think about a compound sentence, right? In English, conjunction, right? And or. I mean, that's pretty much, comma conjunction here. Same thing with this. And is going to be inclusive of both, meaning like intersection. Or means it can be either one. So if I said I am going to Chick-fil-A and Walgreens, you would assume that when I leave here, I will go to both places because I just said the word and. Or indicates if I said I'm going to Chick-fil-A or Walgreens, depending on how important it is I need for something from Walgreens, I'll probably be going Chick-fil-A, right? And if I have to choose between one or the other, then that means the or is okay because I still said the true statement because I said or. So when you think about solutions for inequalities, and means it has to be inclusive of both. So when you're looking at a graph, it is where they cross over or where they intersect each other. That is and. Or would mean wherever it graphs, the whole graph that both of those inequalities hit, all of those are solutions, okay? And so that's the difference between your and your or. For the first one they gave us, it's an and. And graph the solution of 2x is greater than x plus 6 and x minus 7 is less than 2. You're basically going to solve these independently, just like you did the other ones. So we're going to start with the first one and solve that. 2x is greater than x plus 6. This is a rather simple one. Subtract my x. We get x is greater than 6. And then we're going to solve the second one. X minus 7 is less than 2. Add my 7. We get x is less than 9. And remember, this is an and here. And so what we're going to do is we're going to take our two graphs. We're going to take our 6 and we're going to say open circle on 6. And we would shade everything this direction normally, right? And then for the 9, we're going to say, well, that would be an open circle on 9 and we would shade everything this direction. Well, where they cross over is the in-between part. So the only thing that is actually my answer is an open circle on 6, an open circle on 9, and everything in between. All right, everything in between. If they did not cross over, an and would be an empty set, no solution. So if it is an and they do not cross, you have a no solution, okay? That's not true for or, but for and, it can be a no solution, all right? So go ahead and try the middle, page 28, check understanding number 4. And, compound inequality with and. 5, or. So when you have an or, a couple things can happen. They can cross over each other. Typically, if they cross over each other, you get either everything in one direction or you get the whole number line. Or most of the time, they won't cross each other at all. They'll go opposite directions. But you're just going to graph both of them because or means everything that meets either of those is part of your solution. You're still going to do these individually. So I'm going to take the 4y minus 2 that is greater than or equal to 14, and I'm going to solve that one. And I'll get 4y is greater than or equal to 16. And then I'm going to divide by 4. Y is greater than or equal to 4. And then I'm going to solve the other one individually. Add my 4. I get 3y is less than or equal to negative 9. And then I'm going to divide by 3. Y is less than or equal to negative 3. Now what you'll see when I graph these, if I graph the first one, greater than or equal to 4, closed circle on 4, everything bigger. And then if I graph the second one, closed circle on negative 3, and everything smaller. These do not cross, and that's not a problem. The whole thing is your answer because it was or. And so the whole graph, including them going different directions, is your answer, okay? And so with or, it's perfectly fine that they don't cross over. You're not looking for an intersection here. This is a union. This is a union problem. All right, so do at the bottom of page 28, check understanding number 5. The plans for a gear assembly specify a length of 13.48 centimeters with a tolerance of plus or minus 0.03 centimeters. When they say tolerance, they mean just error, allowable error, basically, from what they want. All right, so if they want it to be 13.48, they are going to allow it to be 0.03 centimeters off of that in either direction. That's what they mean by tolerance. A machinist finds that the part is now 13.67 centimeters long. By how much should the machinist decrease the length? All right. So what we know is that we can have 13.48. That is 0.03 centimeters smaller. And we can have 13.48. That, and then adding 0.03 centimeters to that on either side. That's my smallest and largest that I could possibly be, all right? That much we know. 13.48 is what we want. The smallest it can be is if I subtract 0.03 centimeters. The largest it can be is if I add 0.03 centimeters. We also know that the machinist has something that is 13.67 centimeters long. He needs to fix that by taking off some amount so that his length falls in between that, all right? So he has to subtract an amount from what he has so that his length falls in between the least and the greatest that it can be. And so if I subtract this 0.03 from here, what am I going to get? 13 point what? Subtract 0.03. What am I going to get? 13 point what? 4.5. That's the smallest it can be. If I add it, what am I going to get? 13.51. All right. So then we're looking for what does he need to take off of this so that it meets those parameters. So I'm searching for X here. So this is an idea of an and problem. This is 13.45 is less than or equal to 13.67 minus X, and 13.67 minus X is less than or equal to 13.51. This is just where they have put an and problem together, all right? And so you can separate it and solve it that way, or you can just solve it all at once. What you're solving for is the middle here, okay? So when you have a problem like this, your variable is in the middle, and what you're gonna do is you're gonna do the same thing to all three sections. So I'm trying to get everything away from my variable, and my variable is in the middle. So I'm going to subtract my 13.67 so that I'm getting it away from my x, all right? But now I actually have kind of a threefold problem, and I need to subtract that from every piece of it. I subtract it from the middle, but I also subtract it over here, and I subtract it over here, okay? So I want to subtract it from both sides. 13.67 needs to come off of all sides here, all right? All sides here. Now, when I do this, I am going to have my x by itself, but I still have this little bit of a problem. What's in front of my x there? A negative. So I'm going to deal with that as well. So what happens when I subtract 13.45 minus 13.67? What do I get there? Negative 0.22. What do I get on the other side? Negative point what? Yep, 1/6. All right. So my last step to get x by itself, what do I need to divide by? -1. All right. So my x is by itself. I divide this by negative, I get a positive 0.22. What needs to happen here? Flip it. And I divide this, I get positive 0.16, and I need to do the same thing. Now, this is not the nicest way to write this because now you're looking at in between a larger to a smaller. And so they'll typically write it, okay, so he needs to take off between 0.16 and 0.22 centimeters from his length. All right, so anything in between there, and he will fall within the correct range. All right, does that make sense? So anything from 0.16 centimeters to 0.22 centimeters, he can take off that length and he will still be within the correct range that he needs to be in for the machine to work. All right, questions on that one? All right, let's look at this one. The plans for a circular plastic part in a medical instrument requires a diameter of 1.5 inches with a tolerance of plus or minus 0.2 inches. A machinist finds that the diameter is now 1.73 inches. By how much should the machinist decrease the diameter? So we know the smallest it can be is 1.3 and the largest it can be is 1.7. Whatever they make must be in between those two, 0.2 away from 1.5. The diameter is 1.73. So they have to subtract by some amount. And so when you did this, that's your setup, and you should have gotten at least 0.03 inches, but no more than 0.43 inches. At least 0.03, no more than 0.43. And so if you solved it out, you would have done exactly like we did before. Just divide by your negative. Your number or your greater than sign should have flipped, which is where they got no more than that. So between 0.03 and 0.43 inches.
So where does the tolerance come in? Like, does that not have to go in the equation?
This was 1.5 minus 0.2. This is 1.5 plus 0.2.
Okay.